Hello, welcome. Let's try to solve another Leetcode problem. 28. Find the index of the first occurrence in a string. So we are giving a haystack and we are also giving a string needle. So we're gonna find, return the index of the first occurrences of needle in haystack. Otherwise, we're gonna return -1. So for this set, so the first index is gonna be 0. Yeah. So the straightforward way is that we can directly check that. Yeah, we can directly check the haystack. So for example, if this haystack from index 0, it is start with the needle set, so we're gonna return this index. Yeah, so this means for each of the time, basically we need to look through the haystack, and then we're going to compare if it is a start with set. So this is going to be m times n time complexity. Yeah. So maybe we can use this as the idea. So let me just write some code. So it's going to be the haystack. So for I in range n, if this is a haystack from I dot we're gonna use a start with in Python. Yeah, if it is a start with needle, so we're gonna return the I, otherwise we're gonna return -1. This means we didn't find it. Yeah. Currently this works. Yeah, although currently, as you can see, it works, and the speed is also really fast. Yeah, I don't know why it is so fast, but it works. Yeah. So the idea is that we're gonna check one by one. So this is the on time, and here is a start with. Yeah. So basically, this is for each of the time. So for each of the time, it's going to be m times n time complexity. Yeah. So the pattern and the haystack is also 10 to the power of 4. Yeah. So this is because there's no good testing cases. That is why it's so fast. But basically, the time complexity is n squared. N is 10 to the power of 4. Yeah. So this is the easy way to solve the problem. But now we want to optimize the time complexity to m plus n. So instead of m times n. So this is the idea. What are we gonna do? So this is the string matching problem. We're gonna use the string matching idea to solve it. So one of the ways to solve it is KMP, because KMP is really fast and it is m plus n time complexity for solving the problem. Yeah. So here, instead of using the start with, because the start with, this is basically not O1, this is OM. It depended on the length of the needle. Yeah. Now we're going to use the KMP to solve the problem. So now let's just start to use the KMP. So before using KMP, normally we're going to define a Py table, or here I'm going to call it a next table. It is the same as a Py table. So this is a preparation because basically for two-string matching, let me prepare some examples. So for example, if this is a AB, maybe I put it here. Yeah. So if this is a ABCD, ABCDE, and our pattern is ABCDE. Yeah. So this is D, ABCDE. So what are we gonna do? So the brute force idea, or the naive idea, is that we're going to compare one by one, C equal to C, D equal to D, here E not equal to A, and then for the I pointer, we're going to jump to this B, and A not equal to B, and jump to C, and jump to D, and now jump to A again. And now this is a J pointer, and this is the I pointer. We're going to compare again and again. So A equal to B equal to B, C equal to C, D equal to D, and E equal to E. So this means it is a string matching. So this pattern is inside. So we're going to return the index I. But this is going to be m times n time complexity. Yeah. As we can see that this I just go backtracking, just go backward and go backward. So this is why it is m times n. So we want to make it n plus n, so this means we're going to use the KMP algorithm to optimize it. So the I pointer will not go backward, will just go forward instead of going backward. And for the Z pointer, for this pattern, we're going to prepare a table. So this table, we're going to call it the next table or the pi table. Yeah. So inside of the table, I'm going to design such kind of a table. Yeah. So it's going to be index 0 like 1, 2, 3, 4, 5. Yeah. So for the so this is the A B C D E. Yeah. So this is the let me just put it here. Yeah. So the A B C D E gonna start from here. So this is A B C D and E. Yeah. So for the index 0, we're gonna prepare a -1, and for the first character A, so we're gonna prepare table. So it's gonna be 0. So this is the next table. So for B, B is not equal to A. It's gonna be 1, and yeah. Let me just not 1. This is gonna be 0, and this is 0. This is 0, and this is 0 because they're not equal. Yeah. So what happens if this is AB and AB? So what's gonna happen is that in the next table, we're gonna prepare -1. Just prepare the first index 0. We're gonna prepare -1. Just easy for calculation. And now from A, it's gonna be 0, 0. So here, the prefix AB equal to the suffix of this A. So A is the suffix, and this A is the prefix. So this is gonna be a 1. And this AB prefix, this AB is suffix. So for this B, we're gonna prepare 2. Yeah. So basically, we're gonna define such kind of table, and we're gonna calculate such next table, and then we're gonna use the next table to solve the problem. Yeah. So one of the easiest way to write the next table, so this is string S, is that we're gonna prepare a next array and a J pointer. So the next array gonna be starting from -1, and J gonna be starting from -1, and then we're gonna directly loop through the string of the S, and yeah, we're gonna use a while loop to check. So while J more than equal to 0, and Si not equal to Sj, so J gonna jump to the next table of J. So this is what we're gonna write for the next table, and J gonna plus equal to 1, and the next gonna append this J. Yeah. Finally, we're gonna return the next. So let me return a random value 0. And let me just explain what is the meaning of the next table. So here we're going to use the next needle. Yeah. Let me just run it and explain why we're going to use it this way. So for the first example, as we can see from the set, the next table is -1, 0, 0, 0, because S is not equal to A is not equal to this is S, A not equal to S, this D and not equal to S, so it's going to be 0, 0, 0. Yeah. So if we can check from the algorithm, we can also see from it. Yeah. So this is the next table from the beginning, and J equal to -1 here, and then we're gonna check I gonna equal to 0. Yeah. So currently J is -1, so there's no while loop here, but J gonna plus 1, -1 plus 1 is gonna be 0. So this means the next table gonna append a J, gonna append a 0. So inside of the next array, there's a -1. Now we're gonna append a 0. So this is the first step. Yeah. And now I gonna equal to 1, and the Si 1, A not equal to Sj, J is 0, A not equal to S. So this means there's no while loop. So J gonna plus equal to 1, 0 plus 1, and gonna be 1. So next table gonna I'm sorry, this is J equal to -1, because currently this A not equal to S, so J gonna equal to the next table. So next to J, it's gonna be next to 0, so J gonna be -1, -1 plus 1, it's gonna be a 0. Yeah, and similarly for the D. So if it go to the D is not equal to Sj. Yeah, so Si is character D, and Sj is 0. and not equal to s, d not, so this means the suffix not equal to the prefix, d not equal to s. Yeah, currently we're gonna use the d as a suffix. Suffix not equal to prefix, so this means j gonna equal to next j. So next j gonna be yeah, what is the next j? J gonna be 0. Yeah, yeah, currently here j equal to 0. So next 0 gonna be a -1. -1 plus 1 is gonna be 0. Yeah. So this is why we're gonna use this kind of algorithm to solve it. Yeah. So this is for SAD. So what about AAA? So what about let me use a testing case for the first one. What about we use AAA? Yeah. So what's gonna happen? Let me just yeah, the needle gonna be AAA instead of the haystack. Yeah, we can still say that in the first example, this AAA, but the next table gonna be -1, 0, 1, 2. Yeah, so this is gonna be the same. So first of all, we're gonna have a -1 inside the next array, and now because it is equal, so there's no check for the while loop. So j gonna plus 1. So from beginning j is -1, no plus 1, j gonna be 0, and we're gonna append it. Yeah, currently j equal to 0. And next, for the I, if I equal to the next a in the middle, so j gonna plus 1, so j gonna be here gonna be a 1. And the next, for the last a, j gonna plus another 1, it's gonna be 2. So this is why the next table is -1, 0, 1, 2. Yeah. So currently, if we understand this kind of algorithm to calculate the next table, normally we can solve the problem easily. Yeah. Now we're going to use this kind of a pattern to solve the problem. So from the beginning, we're going to prepare a next array. So we're going to call the next function. Yeah. So here we're going to call the pattern. But before that, let me just prepare the string and the pattern. So the string going to be the haystack, and the pattern going to be the needle. Yeah. And here going to be the next array. Now I'm going to prepare an index j, going to be starting from 0. So this j is starting from 0 instead of a -1, because I'm going to use it for the first character for comparing inside the needle. Yeah, so for inside the needle, I'm going to compare the first character with the first character inside the haystack. And then I'm going to use this next table. So here going to be the same. So for I in range length of s, so we're going to compare if j is more than or equal to 0, and this si here we're going to change it to pattern j. Yeah, so pattern j is pattern 0. Yeah, if the first character not equal, we're going to use the next table. Yeah, if it is not equal, we're going to use the next table. If it is equal, j going to plus 1. Yeah, now we're going to check this j. If j equal to the length of the pattern, yeah, so j is coming from the 0. If there's a character equal, so j gonna plus 1. So for example, if this is a character, let me use it from here. Yeah, if this s equal to s, so j gonna plus equal to 1, j gonna equal to 1. If a equal to this a, so this means j gonna equal to 2. If this d equal to this d, j gonna equal to 3. If this is j3 equal to the length of the needle is 3, so we can return the final result. Yeah. So the final result is gonna be the index I minus the length of the pattern and plus 1. Yeah. Yeah, because we are checking the index I from the haystack. So the index I is currently it is yeah, so index I, so this d equal to this d, so j gonna plus 1, j gonna comes to this d, and yeah, let me check the index I. Index I gonna be at this b. Yeah, so currently index I is equal to 2 at this character D, because they are equal. Yeah, because this character D, they are equal, so they equal to 3, and I gonna be 2 character. Currently I is at this D, I gonna equal to 2. Yeah, so I is at 2, but we need to find where is the beginning. So I is at 2, so 2 gonna minus the length of the pattern 3 and plus 1, so it means it is at index 0. Yeah, so it is the same idea. So for example, this is the I at index 4. Currently this I is at index 4. This is the end of the needle, end of the pattern. But if the length is 3, so what's gonna happen is 4 minus 3, it's gonna be 1. Yeah, but if 1 to 4, it means the length of 3 is 4. It's not right. It's gonna minus 1. It means it's gonna be start at index 2. So this is the idea. Yeah, so this is why we're gonna use I minus the length of the pattern plus 1. If we cannot find, we're gonna return a negative 1. Yeah. Now let me just run it have a check. Now as you can see, it works. Yeah. Now let me submit it to check if it can pass. As you can see, it passed for all testing cases, and it's pretty fast because the time complexity is O m plus n. So m is length of the haystack, and n is the length of the needle. Yeah, now it becomes linear. And for this question, this time I just used some examples to explain why we can use this algorithm to solve the problem. Thank you for watching. See you next time.